Greetings. In this video, we're going to deal with the area enclosed within a loop. This is suitable for years 17 and above. So the problem is to find the area of a single loop of the function, and in brackets x squared plus y squared, and that's all cubed, equals 16a squared x squared y squared. Now that looks a little bit daunting, but here we will use a substitution, letting x equal r cos theta and y equals r sine theta. That's known generally as switching to polar coordinates. So substituting in those values, we'll have on the left-hand side in brackets r squared cos squared theta plus r squared sine squared theta, and the bracket is cubed. And on the right-hand side, we'll have 16a squared r squared cos squared theta times r squared sine squared theta, which comes down to on the left-hand side, we would have inside the bracket r squared times cos squared theta plus sine squared theta, which is identically 1. So inside the bracket you have r squared, and when you cube it, you get r to the power 6. And on the right-hand side, quite easily, 16a squared r to the 4th cos squared theta sine squared theta. And now square rooting that, we get r cubed equals 4a r squared cos theta sine theta, which equals 2a r squared sine 2 theta. And so r is equal to 2a sine theta. So a loop will be described when theta travels from 0 to pi upon 2, because at both those values, the function reduces to 0. Okay. Now, looking at the diagram, the area of the element OAB is it's approximately a triangle, so it would be 1/2 r plus delta r sine delta theta. And in the limit, that reduces to 1/2 r squared d theta, as delta theta tends to 0. So the loop area is the integral between 0 and pi upon 2, 1/2 r squared d theta, which equals 1/2 integral between 0 and pi upon 2, 4a squared sine squared 2 theta d theta, which simplifies to 2a squared integral between 0 and pi upon 2, 1 minus cos 4 theta over 2, integrated with respect to theta, so equals a squared bracket theta minus sine 4 theta upon 4. That's performing the integration to evaluate it between the limits 0 and pi upon 2, which comes down to a squared times pi upon 2, or pi a squared upon 2. And that brings us to the end. Thank you very much for listening.